right. Hi, everybody. It is Monday. We're outside. We are not building anything today. I'm sorry. If you were wanting to build something today, we're going to work on the HR diagram today. And this is usually a lab that we do in class with all of us together. And we don't get to do it that way this year. And so I'm going to do it. You're going to get to watch. And you've already done a couple of lessons on the HR diagram. So you may come up with the answers for this faster than I do. All right. So on the HR diagram, we have the luminosity is graphed on the y-axis, and you'll notice that these are like 10 to the negative fourth power, 10 to the negative second power, 1, 10 to the second, 10 to the fourth, and 10 to the sixth. And you've maybe never done a graph that looks just like that. So let's talk about it. If it's to a negative power, that means it is less than 1. And it very quickly becomes a whole lot less than 1. So it's a decimal number. 10 to the second power means 10 times 10. So 10 to the second power is the same thing as 100. 10 to the fourth power is 10 times 10, with there being 4 tens. And so it ends up being 10,000. 10 to the sixth power is 10 times itself 6 times. So you've got 6 zeros. So that it's a really big number. Okay, so we are going to up across on this graph, it's across the top. Sometimes they put temperature across the bottom, and it doesn't really matter where you put it because you still end up graphing it the same. But the really weird thing about the HR diagram is that 40,000 Kelvin is a really huge number. 3,000 Kelvin is a lot smaller, but it's way over here to the far right, okay? Usually, when you're looking at a graph, this is your tiniest number on your y-axis, so it's also your tiniest number on the x-axis. Usually that intersection is 0 for both of those. It is different on the HR diagram. Here, for our x-axis, is a really, really large number, okay? Right here is larger than 40,000. And then way over here is going to be smaller than 3,000. Okay, so this part runs a little backwards than what you might expect. So it also has the spectral classes on it, and we do not talk a whole lot about spectral classes, and I'll be honest with you, on this graph, they're in the right order, but I don't think they're spaced out correctly, and so it may be a little bit off on spectral class. We're going to focus on luminosity and temperature. Okay, so let's start putting stars on here. Okay, so I took the stars off because we're having two-sided tape issues, but it's better now. Okay, so here's the sun, and the sun's temperature on here, it says 6,500. It's actually 5,500. So it's going to be in this line, and then it's got a 1 for luminosity. So we go 1 and 5,500, and so the sun graphs right there. Then we have Sirius. Sirius's temperature is 15,000. So Sirius's temperature puts it in this line, and its luminosity is 10. So it should go about right there. Then we have Alpha Centauri A. Its temperature is 6,000. So it's really close to the sun. And its luminosity is 1, so it's still really close to the sun. So Alpha Centauri A graphs really, really close to the sun. Alpha Centauri B, its temperature is 5,000, and its luminosity is 1, and so it is also really close to the sun. Okay, now let's graph Vega. Vega is 10,000 degrees, so it's in this line, and its luminosity is 100. So its luminosity, it should be about here. Barnard star, its temperature is 3,000, so it's over in this line, and its luminosity is 0.001. So it's down here with the negative 10 to the negative 2. and 3,000. Let's move it over a little. Okay. Spica, its temperature is 30,000. So it's over here. And its luminosity is 10,000. So up here for luminosity. Okay. Now we have Sirius B. Sirius B is really little. And its temperature is 10,000. Okay, so it's in this line. And then its luminosity is 0.001 for luminosity. So it goes here. Aldebaran, its temperature is 5,000, so in this area, and luminosity is 100, which is about right there. Okay. Now we have Betelgeuse. Betelgeuse's temperature is 3,000, so it's going to be in this line, and its luminosity is 20,000. So it goes about here. And Antares' temperature is 3,000, and its luminosity is 10,000. So it's the same temperature as Betelgeuse and Barnard's star, but it is a little less luminous than Betelgeuse. And those are all the stars that I got together to put on our graph. What I want us to notice is we have the diagonal line that goes from the upper left to the bottom right, and the stars that graph in that area are called main sequence stars. So these guys are main sequence, and this is main sequence, and Barnard's star is also main sequence. Sirius B, we talked about how little Sirius B is, and then also its luminosity is really tiny. And it is part of the dwarf stars that are in this area. And then Betelgeuse, Antares, and Aldebaran are part of our giants and our supergiants that go in the upper right part of the HR diagram. So thank you guys, and I hope you enjoy your Outside Monday.